Day 15 of 90. Your C++ class compiles clean, passes every test, then corrupts memory 3 function calls later in production. No warning, no crash at the call site, just silent heap damage. Today we figure out why, by taking a broken resource handle and rebuilding it into a class that physically cannot leak. If you've ever written a struct that holds a pointer, this one's for you. Here's the crime scene. A struct called fileHandle, a raw file pointer and a name string, both public. You open the file in your code, store the pointer, and move on. It works in the demo. But nothing guarantees that pointer is valid, nothing closes it when you're done, and nothing stops a second copy from grabbing the same handle. This is a data bag pretending to be an object. A struct stores state. A class enforces a promise. Step 1, make the promise at construction. We turn it into a class, make the pointer private, and write a constructor that takes a file name and actually opens it. If open returns null, we throw, the object refuses to exist in an invalid state. That's the whole idea of an invariant. From the instant construction succeeds, the handle is valid, and there is no public path to make it otherwise. The constructor isn't setup code. It's a guarantee. Step 2, who closes the file? The destructor. We add a tilde file handle that calls close on the pointer. Now the resource's lifetime is welded to the object's lifetime. When the file handle goes out of scope, the OS handle is released automatically. This is RAII, resource acquisition is initialization. Acquire in the constructor, release in the destructor, and you never write a manual cleanup line again. The compiler runs your destructor for you, even when an exception unwinds the stack. Now watch it explode. We copy the object, pass it to a function by value, or push it into a std vector that resizes. The compiler generated a copy constructor for us, and it does a member-by-member copy. That means it copies the raw pointer, the address, not the file. Now two file handles point at the same file. The first one dies, calls close. The second one dies, calls close on the same pointer. Double free. That silent corruption from the intro? This is it. Pause, because this is the core lesson. The moment your class owns a resource, the compiler-generated copy is wrong. This is the rule of 5. If you define a destructor, copy constructor, copy assignment, move constructor, or move assignment, you almost certainly need to think about all 5. The compiler generates them by default, and for a pointer-owning class those defaults do a shallow byte copy, exactly the bug we just hit. The fix isn't patching the copy. It's deciding what copying even means for this type. For a unique file handle, the answer is, you can't copy it. So we write copy constructor equals delete, and copy assignment equals delete. Now any attempt to copy a file handle is a compile error. The double free is impossible before the program ever runs. But we still want to move it, hand ownership from one object to another. So we define a move constructor that steals the pointer and zeros the source.ptr equals nullptr. Now the moved from objects destructor sees null and does nothing. That's the whole design. Construction validates and acquires. Destruction releases. Copy is deleted because sharing the handle is meaningless. Move transfers ownership and leaves the source safely empty. Compile it, run it under Valgrind, and you get 0 leaks, 0 invalid frees, clean. Not because we sprinkled in a null check, but because the types interface now makes the wrong thing unexpressible. That's the shift. We didn't patch a bug, we changed the design so the bug can't exist. A class is a promise written in the constructor and destructor, not in comments. Day 15 done. The takeaway: when an object owns a resource, the rule of 5 isn't optional. Decide, copy, and move on purpose. Subscribe for day 16, where we make this generic with templates. Word count: 770 words, within the 750 to 850 target for a 5-minute video.